welcome back. Before we get started today, I want to do a little mini lesson on the whiteboard because some people brought up some really awesome questions in the small group meetings, and so I thought I'd do a little refresher. We've been talking about ratio, or ratios, as Leonardo calls them, for a while, and we've started recently talking about rate and unit rate. So I kind of want to talk a little bit about the difference of those. They really work mathematically, they work exactly the same. Ratio is comparing an amount to an amount. A rate is when you're comparing two different units to each other, miles per hour, dollars to bananas, whatever, different units. And then a unit rate is when you're looking for the one of something. So how long does it take you to go 1 mile? How far can you walk in 1 hour? How many bananas can you get for $1? Things like that. Or how much dollars does 1 banana cost? You can reverse them. So I have this here, this rate. You can get 8 sodas for $12. Okay, so this is a rate. It's comparing different units, sodas and dollars. And I want to turn this into a unit rate because I want to know how much 1 soda will cost. So if I want to find out what 1 soda will cost, and right now I know what 8 sodas will cost, what I'm going to do is divide both things by 8. If I divide 8 by 8, I'll get 1. So that'll be 1 soda. So let's divide 8 by 8, which will equal 1. And now because I did it to that part of this ratio or rate, I'm going to do the same thing to the bottom part, the other term. I'm going to divide that by 8 also. So as it happens, 12 divided by 8 equals 1.5 or 1.5. So now I have a unit rate. Now I know that 1 soda costs $1.50. Okay? So that's one way to find a unit rate from here. What if I wanted to know how many sodas I could get for $1? Well, the 12 represents the dollar value, okay? So if I want to find that, I have to divide both sides by 12. Because if I divide $12 by 12, I get $1, right? Now I'm going to divide 8, which is the number of sodas, by 12, and let's see what happens. Okay, I'm going to write that out here, dividing 8 by 12. I have to add a decimal point and a 0. And then let's see, 5 would be 60, so 6 would be 72. And then I have 8 left over, which is 3/4 of 12. So I get 0.675. So that means that let's see, what am I dividing here? That means I can get 67 or 675 7/100ths. I can get that much of a soda. About 60% of a single soda for $1. That's kind of an odd unit, but that's how it works. Okay? All right, so that's rates and unit rates, just a little refresher. Now let's go to our workbooks. We are going to start on page 287. Okay, so with 10 and 11, it says, write each statement as a rate. Well, it's almost like a rate already. All you have to do is like this. 9 full moons in 252 days. Okay? So it took Hannah 38 minutes to run 8 laps as a rate. 38 minutes for 8 laps. Nothing too earth-shattering there. All right, let's look at 12 and 13 where we're finding the value of x. We've got a couple of different ways to do it here. Here the information is displayed in a table. Here it's displayed in a double number line. Let's look at the table. So it's about fish in bowls, and you can put 16 fish in 2 bowls. Okay, what it wants to know is how many bowls will you need for 48 fish? So there's a couple of different ways to do this. One way is to find the unit rate. What if I find out how many fish you can put in 1 bowl? Let's try that. So to do that, I'm going to divide, since I'm looking to get it down to 1 bowls, I'm going to divide 2 by 2 and get 1. And then I'm going to divide 16 by the same thing. I'm going to divide that by 2 and I will get 8. So now I've found the unit rate of fish to bowls, and I know that I can put 8 fish in 1 bowl. Now, if it asks me how many bowls I need for 48, well, I know that 8 goes into 48 6 times, so I'm going to need 6 bowls. You might also notice that 16 is 1/3 of 48, so you could just multiply the number of bowls by 3, and you'd still, of course, get 6. All right, let's take a look at number 13. Double number line, we have miles and hours, and they've got this broken up into 4 sections, and the complete ratio or rate is 184 miles to 16 hours. And then we have some other values that are plugged in there. And this is what we want to find. How many miles in 4 hours? Okay, how would you go about solving that problem? If we know they can go 184 miles in 16 hours, and we want to know how far they can go in 4 hours. Again, there's a couple ways you could go. You could find a unit rate by dividing 184 by 16 and then multiplying it by 4. Or you might also notice that 4 times 4 is 16. So in that case, if you divide 184 by 4, you'll get that answer. Let's try that. 184 divided by 4. Let's see, 4, and that's 16 with 2 left over. Bring down the 4. 4 will go into 24 6 times, so 46. Okay? All right. Let's take a look at the next section here. In 14 and 15, find the unit rate. Remember, unit rate is when you're getting down to 1, and it kind of shows you a formula for how to do it. Our original rate is 320 miles to 16 gallons of gas. And then it shows you to get it to a unit rate, down to 1 gallon of gas. They divided 16 by 16 to get the 1, and then they divided the other term, 320 by 16, to find the amount of miles you can go in 1 gallon, on 1 gallon of gas. And then 15 works the same way. So this is 75 centimeters to 5H. What in the world does that H stand for? Hours, maybe? I don't know. Either way, we're looking for a unit rate here, so they've set it up for you. 5 divided by 5 is 1. 75 divided by, what are you going to divide it by? And what is it going to equal? Okay, do those couple of problems and then come back to check your work. Okay. Whoops, wrong page. All right, so you should have gotten 20 miles to the gallon for 14. I just divided 320 by 16 and got 20. And then for the next one, you should have gotten 15 centimeters for 1H, whatever H stands for. Okay, now let's look at those tables. There's some more rates there. Pages to minutes, beans to bags, ounces to bags, and miles to gallons. And in each of these tables, they have some of the values filled in for you, and you have to find the missing value. They don't like leap in order though. If you notice for the minutes, it goes from 18 to 1, and then to 10, and then to 15. So you have to start with your original rate and then figure out what the other ones would be. Okay? I would find the unit rate here, and then you'd have that one filled in. So 9 and 18, and I want to know what it is for 1 minute. I'm going to divide 18 by 18 and I'll get 1. That means I have to divide 9 by 18 also. And how many times will 18 go into 9? 1/2 of a time, or 0.5. So now I have a unit rate. And now that I know that 0.5 for every 1 minute, when I get to 10, all I have to do is say, well, 10 times 0.5, which equals 5. And then when I have 15, I just have to say 15 times 0.5, which is 7.5. Okay? Try these other tables and start the video up again when you're ready to check your work. Okay, so for number 17, 62 for 1 bag, 434 for 7 bags, 682 for 11 bags. And then for 18, we've got 12.3 for 1 bag, 24.6 for 2, 61.5 for 5 bags, and if you have 123 ounces, you need 10 bags. And then for 19, you've got 25 for 1 gallon, 75 for 3 gallons, and 300 for 12 gallons. Okay? All right. Let's look at the next page. Okay, so we have a table here, and we've got the runners' names, and then we've got the number of laps that they ran and how long it took them. And the question is, which runner set the fastest pace? So this is definitely an example where unit rate helps you out. Because if you look at it right now, because they all did a different number of laps, you can't just look at their time, right? And say, oh, well, she ran the shortest amount of time, so she must have been the fastest. Not necessarily, because Martha ran more laps. It took her longer, but she ran more laps. So you can't just look at the table. You have to find out how fast, what was their unit rate per lap, okay? So how would you do that? If you divide the amount of time they ran by the number of laps they ran, you'll get how long it took them to run each lap. And then you'll have something you can compare. Why don't you stop now and do that? Find out what their rate per lap was, and then, of course, who was the fastest. Pause the video and come on back when you're ready to check your answer. Okay, Allison was the fastest. It took her 1.56 minutes per lap. And it turns out that both Martha and Rachel took 1.6 minutes per lap. Okay, let's look at the rest of these problems. Over the summer, Alexis read 15 books in 12 weeks. The diagram below can be used to track her progress. If Alexis read at the same rate each week, how many books had she read in 4 weeks? In 8 weeks? Complete the diagram. Okay, so you can see at the end of this double number line, they have 15 and 12 weeks. So they tell us that at the beginning. Then we have these values filled in, And what we don't know is how many books read in that amount of time. So what would you do to solve this? We know that she can read 15 books in 12 weeks. I wonder if we knew how many books she could read in 1 week, could we then just multiply up? Yes, we could. But I also see another way. Do you see it? Look at these numbers along the bottom. 4, 8, 12. And then what do you notice about 15 and 12? Do they have a factor in common? So 4 is 1/3 of 12, right? So that means that she ought to be able to read 1/3 of 15 in 4 weeks. Because if you divide 4 by 3 and 15 by 3, you'll end up with 4 weeks and 5 books. Now let's look at this other missing one. Well, 4 and 8. 2 times 4 is 8. So what if you just multiply that by 2? And then you would get 10. Make sense? Okay, let's look at the elephant. Okay, now we looked at the elephant. Now let's do the math problem connected with the elephant. An elephant charges an object that is 35/100ths of a kilometer away. How long will it take the elephant to reach the object? If an elephant is ever charging you, I would not stop and calculate how long it's going to take. I would just run. I would just run as fast as you possibly can. Okay, elephants can charge at speeds of 0.7 of a kilometer per minute. And it's 35/100ths of a kilometer away. How long will it take the elephant to reach the object? All right, let's take a look at number 23. A machine takes 1 minute to fill 6 cartons of eggs. At this rate, how many minutes will it take to fill 420 cartons? Okay, so 1 to 6. And then what we don't know is how many to 420. Think you can do that one on your own? I do. How about some higher order thinking? How are the ratios 24 laps for 1 hour and 192 laps for 8 hours alike? How are they different? What do you think? Look at those numbers, compare them. What do they have in common? Okay, why don't you do those 3 and then unpause the video when you're ready to check your answers. Okay, so 30 seconds. It would take 30 seconds for an elephant to charge 35/100ths of a kilometer. Half a minute. Run. Okay, and here's how I did this one. If I knew that it took 1 minute to fill 6 cartons, I divided 420 by 6 and found that it would take 70 minutes to fill 420 cartons, or an hour and 10 minutes. Okay, now, how are they similar? How are they different? They're rates and they're equivalent. That's how they're different. They're expressed in a different way, but they're both rates and they're both equivalent. Okay, now let's look at these last couple of problems. A cook mixes 4 pounds of rice into 5 quarts of boiling water. Choose all the statements that are true. All right, you have to look at these carefully, and this is again a time when you might want to think about unit rate, because there's these different amounts and they're showing them different ways, so it's hard to tell whether it's true or not. To make it true, it has to match this, 4 pounds to 5 quarts. So you have to find all the things that are equivalent ratios to 4 to 5. Do that one on your own and come back when you're ready to check your answers. Okay, so 0.8 of a pound of rice to 1 quart of water is a unit rate for that. 1 1/4 quarts of water to 1 pound of rice is a unit rate for that. And then using the same rate, the cook should mix 10 pounds of rice with 12.5 quarts of water. That also matches this. The other two do not. Okay? All right. Jimmy, what are you doing? Looking at the cats. Okay. All right. So good work today. We'll see you tomorrow, and tomorrow will be our last math lesson. I'll see you then. Bye.